Okay, perfect. So I have started the recording and am I audible? Yes, I am audible, right? Okay. So guys, let me just share my screen. And in the last class, we were like discussing about the convolutional neural network, and we have implemented one technical part as well. It was like completely related to the CFAR dataset, right? Okay. Now on today onwards, what we are going to understand, we have a one project that is called convolutional neural network flowers classification. Okay, and we'll try to develop this project end to end because the session is of 2 hours of today. So we'll try to complete this ASAP, whatever it is possible, right? Okay. So now let's just understand the objective of this project, right? In this project candidate, we have 5 different classes, and the 5 different classes are like Daisy, Dandelion. Well, the image quality is not good. Just to ignore this one, right? We have 5 different classes: Daisy flower, Dandelion, Rose flower, Sunflower, and the Tulip one, right? Okay. So this is very popular data set, and you can download this data set from the TensorFlow itself, and you have to create a model. Okay. Now let's just quickly understand this data set, right? So let me just simply write this as Sunflower, Tulip, Dandelion, and Lily, I think, was it the Lily? Okay, so is Daisy, right? So just write this as Daisy, or let me just write directly as TensorFlow dataset. Okay. So when you call this dataset, now, so you will get something like 3,670 images of five different classes of this flower, right? And you know that this flower is generally stored in a form of np.array, right? So what we are trying to do, we just try to call this data set. We can call this method, right? And with the help of this method, we can data. So that the data set is stored in a form of array. We can simply store all the data set, and then we'll try to pick one data each one by one, and then we'll train our model based on that, right? So let me just quickly call all the modules, and let's just quickly start the project part as well, right? Okay. So first part that you have to do is to call all the important modules, load important modules. Okay, so the code part is very lengthy, right? So let's just quickly start this one. You are already aware of the multiple modules. You have to call OS module, right? Let's just simply call the turtle, not the turtle. We have one module that is called tar file. This tar file helps us to quickly download the zip file from the online sources, and you can simply unzip this file. Okay, if you don't know this module, so you have to particularly go to the website. You have to download that zip file. Then you have to your module to particularly call the have to request URL. So we have another module that is called URL lib. UR library allows us to particularly you can hit any of the URL, right? Candidate URLIV, and inside this you will get this one method which is called request method. With the help of this request method, you can directly call any of the URL, right? Okay. Now let me just call another library that is called pathlib. With the help of this pathlib, okay, there might be chances the module is not available, so we have to download this one. Let me just copy this. You can simply write pip install. Okay, and one more thing, I'll just simply request to everyone, because I'm connected on my mobile internet, so there might be chances the internet connectivity will not work properly. Okay, so you can simply let me know in the message area, right? So that I can understand the problems if you will face, right? So let's just simply install this module, right? Pip install URL library 3. You can simply run all the modules like here. Let me just copy and paste this one. You are using this exclamation mark to run this run this code as a like a compile mode, right? So you can call this one. Okay. Now let's just call another modules, because we want to resize our images, whatever the images that we are calling. So we have to resize. So for that, you have to use this CV2 module. CV2 is like OpenCV module. We have already discussed this one, right? Now just simply call the numpy module. Just simply call the matplotlib module, matplotlib.pyplot. Let me just zoom out this, matplotlib.pyplot as PLT. You can call the C1 module as SNS. Okay, so these are the basic modules that we are calling, right? Let me just quickly run this as done. If we are facing any issue now, so this will helps us to understand what module that we are not able to download. Okay, so we are facing problem related to UR library 3. So let's just quickly run this code, pip install your library 3. Okay, now can you understand one thing? This Google Colab gives you the GPUs and TPUs access, right? So in the last class, we were not able to train that model timely. So what we are going to do, we can just simply click on this and you can click on this change runtime. And this will give you the access of GPUs and the TPUs, right? So you can select this T4 GPUs like the Tensor 4 that we are using, and that this has been built by the Google itself. So you can directly access the graphic card of the services provided by the Google itself, right? So let me just change the runtime, and now I can quickly build my TensorFlow model. And if I'll face the like training set of issue related to the model training, so we can simply call this T4 like T4 kind of graphic card, right? So let's just quickly install this, pip install URL library 3. It will take some time. Okay, requirement already satisfied, but why we are not able to call this? Okay, so my mistake. It is it not just the UR library, it is URL library, right? So simply call this one. Okay, now it will definitely print the done. Perfect. So in this way, we have imported the basic module. Now let's just call the important module. So you can simply call the TensorFlow from TensorFlow. We know that with the help of TensorFlow, this will give you the Keras method. And with the help of this Keras method, you can call the models that you want to particularly build on, right? And because we are working on the deep learning, so we have to call the sequential model. Sequential will allows you to particularly like add each individual dense layer one by one, right? Now let's just call another module from TensorFlow dot keras. Inside this, you can call this and you can call multiple like convolutional neural network. Now, so we have to call multiple layers, right? So the first one is convolution 2D, right? I hope everyone is aware with that. We have used this in the last class, right? And once you start with the convolution, then you have to call the max pool as well. It is for the max pooling, right? Then we have to flatten the layer, so you can call the flatten. Then we have to build the dense neural network. You have to call this one. Okay. In the last class we had already discussed this concept, which is called the image augmentation, right? Let me just show this again. Image augmentation techniques for deep learning. What exactly this image augmentation is? This allows us to particularly create a multiple samples of a given images, right? If you're getting any simple image, so with the help of that single image, you can create multiple images. Like we are having this one single dog image. So what we are doing, we are just applying some random flips, random contrast, random brightness, and we are creating multiple samples of a given single images. The technique is called the augmentation technique. Okay. If you are creating your model now, so the black rose is also a rose, a red rose is also a rose, right? So the model should be able to configure the difference between the different set of saturations, colors, and brightnesses as well, right? So we have to call this one augmentation technique, right? So how to call this one? Again, this is a part of this layers, right? So you can just simply apply this backward slash because we want to call multiple models. So let's just call this as the random flip. We want to like randomly flip our random array and DOM random flip. We want to particularly flip our data set, right? So we are calling this one. Okay. So this is a part of what data augmentation candidate, right? Now you can simply call the random rotation as well. Random rotation. Okay. And you can call the random contrast as well. So let's just call the random contrast where we can simply give the contrast to our images, right? Okay, now let's just try to run this one. Is there any issue? Let's just use the comma here. Okay, because this allows us to particularly call multiple methods in a multiple line, right? Let's just simply write the done here. Yes, we are getting, right? Okay, now let's just call another modules from this TensorFlow itself. So go to this TensorFlow, call this Keras, and inside this Keras, you will get the optimizer. We have already used this one. we have multiple optimizers. You can call the Adam optimizer, you can call the ADA grade optimizer, and the rest optimizers you have, right? So you can call any of them. Well, the main important one is the Adam optimizer, right? Now the rest modules is like from sklearn we have to call the train test split. So let's just quickly call this from sklearn dot model selection. You can call import train test split, right? Again, go to this from sklearn dot matrices. You can call the, because the project is related to not the binary classification. Right now we have the 5 different classes, so we have to call multi-class classification na? So we have to call the confusion matrices as well, right? And the classification reports. Let's just call the classification report. And if you want to call accuracy, precision, recall score as well, you can call this one, right? So let's just call the accuracy score again, right? Okay. Now we have simply called this one. Now what we want to particularly call the rest module so that we can simply initialize our models, right? Okay. So let's just call TensorFlow again, because inside this TensorFlow we have multiple sub layers that we can particularly build our model for the import TensorFlow as TF. You can simply give the aliasing as TF, right? Okay, we have imported Keras model, sequential convolution, 2D, 3D, 2D MaxPooling, flatten dense layer and all, right? Okay, so inside this TensorFlow, you can call one more thing, which is called the layers and the models. If you have like any other sort of layers that you want to build, whether it is again convolution, 2D, 3D, or some sort of any of the layer, you can call this one, right? So let's just simply call inside the model selection, we have used this train. So call Keras, and inside this Keras you can call the layers, and the second one is model. Okay, so these are the final modules that we have called, right? This is all about for the step 1, all modules loaded successfully. Okay. Okay, now why we are getting some sort of like warning here? Because the the Google Colab is not still able to recognize we have this module, right? Okay, so in this way, candidate, we have imported all the required modules that we want to particularly build this project, right? Now the second concept, we have to call the data set, and we know that we have imported this module which is called the tar file. It allows us to particularly call the data set. So we have one URL, and with the help of that URL you can call the data set. Okay, so now let's just simply write this as, let me just write this download dot tensorflow dot org. This will you have to simply write this one, example of images, and images of what? The flower photos, right? So let's just write this as flower photos dot tar file. So we simply say this tar file as dot tgz file, right? Now if you just simply click on this, this will give you the URL, right? And with the help of that URL you can call your modules, right? So just wait for a while, candidates. Okay, where is the URL? This is the dataset. Okay, now you have to call this link. You can take a copy of this one, right? And because the link should be in a HTTPS format, because you have to simply pass the protocols as well. So just simply copy this one, go to your notebook, simply write this as a data URL. Whatever the constant value that we are creating, it's recommended to pass this inside the caps variable, right? So you can simply call this as a string, and we are not simply using the HTTP link. We have to be follow the protocol. So this should be secure and safe. So you are using this HTTPS. Now you are just using download.tensorflow.org example images flower dot something this. Okay. So now the problem is we have to use the Google APIs that allows us to download this one. So what you can do, can you just simply write this word here, right? STORAGE storage dot Google APIs .com and keep the slash like this. This is the final data URL that you can use. Help of this request module, we just Am I audible now? Just quickly confirm me this multiple times, right? Because again, I'll repeat, I'm connected on, I like with my mobile phone, so I have to only again. Example images, something so like this. Okay, just wait for a while. Let me just quickly check, guys. Confirm me. Am I audible now? You can just let me know, right? You either you can click on emojis as well, right? Okay. Yes. Now it's perfectly working. Okay. If you just simply click on this now, you can download your data as well, right? But what we want to download it using the Python now. So we will use the pathlib module or like the UR library request module, right? So let's just create another directory that is called data directory. And we want to create a folder here inside the Google Colab itself. So you can just simply write your directory name, and it is like flower underscore data. With the help of this one, we are creating a directory, right? And whatever the images that we are getting candidate, we have to be reduce the image size up to the required dimension. See, user can simply give any of the data sites or any of the images, right? If they want to predict the flower nut, so they can give any images size. So you have to particularly make sure that the images size should be this, and you can particularly toggle this. You can change the value, right? Okay. Now, if we want to train our model, so these are the constant value that we are keeping on. So the bias size, we will simply pick 30, 40, 50, 60. You can pick any of them, right? Okay. And the number of epochs that we want to epochs, the number of epochs that we want to like train our model on is called 30. Okay. Now, why we are using this capital variable? So these are called the constant that generally does not change in future. Okay. If the user want, they can simply change this one. Okay. So these are the basic configuration that we are performing, right? Okay. Now let's just try to download this data set. Okay. So what you can do, you can just simply try some if and else approach. So let's just simply call this as URL library. Inside this URL library, you will get one method that is called request method. And inside this request method, guys, you will get another method that is called UR library retrieve. You will get one more method which is called retrieve, right? And inside this retrieve, you have to give the URL that you want to download the data for. Okay. Now let me just simply give this one, and we want to download this data and keep this data set where. So you can give the you can give the folder as well, or second thing that you can give the file name as well. Okay. So let's just simply download, keep this file name as a flowers. This is my flowers or dot just you have to apply some if and else method. Now let me just write this. If we have one module that is called OS module, let me just run this. OS module allows us to extract the path. So inside this os.path, you can just check whether this directory exists or not. Okay, and I'm checking about this directory. Which directory? This one. Does this directory exist? Let me just run this. It say false. So now what you will try to do, you will try to create this directory, right? Because if this directory exists, so the data is already exist. And right now we have just simply created this variable now. So we are just checking this directory must not exist. So we will write the if condition, but it should be in a opposite case, right? If not, and we know that this generally code will return a false. So if you just simply pass this using the if not method, it will convert to true, right? And we are just checking if this path not exists, then what we are going to do, we will simply hit this URL with the help of a data URL. We have this data URL, and this will download the file in a sort of flowers.tzz extension, right? And if you just simply run this now, this will give you two different answer. The first one that will give you is called the tzz file, and second one is their metadata. So if you want to ignore the metadata, so you can use this underscore, right? Because we don't want to store this metadata, right? See, if you want to run for loop, right? This is very important concept. If you don't want to use this iterator, you just simply want to run the for loop. So it is not recommended to store the value inside this iterator. What you can do, you can simply run with the help of an underscore, right? This underscore will definitely run the loop, but we are not going to store any of the value, right? That is the main reason. That is the main reason of using this kind of underscore approach, right? In the same way, we are using this underscore method because if you just hit this URL, now this will give you the metadata, and you are not interested in this metadata. What we want, we just want to use this tzred, or this is a tar file, right? Because this is a tar file or like a binary file, so you have to use the binary file handling. And this binary file handling can be done with the help of a tar file function itself, right? Inside this tar file, you'll get the open method. Now we are going to open our what? We are going to open our file. And we know that the file is stored in a form of tzz file, okay? And we want to read this data candidate, right? But this is not exactly the binary file. So, okay, we will read this data, but this time this is not the. So we will write this as a gz. Gz is like for unzip this file and simply consider the variable name as a tar file. Now what we want, we want to extract all the data in whatever the data directory we have. Okay, it will take some time. It will try to consume the internet data, and then it will probably download the data inside the given folder, right? So let me just simply write this as tar variable, and we have this method that is called extract all. And what we want to extract, we want to extract all the tzz file inside where you can just simply give the folder data directory. We want to extract all the file data here. Okay, now let me just quickly comment out this one. Okay, and simply just check candidate. Just let me know, confirm this once again, guys. Am I audible now? Candidate, everyone has to confirm this once again, right? Because again, I'll repeat, I'm connected on my mobile internet. There might be chances to disconnect with the audible part, right? Okay, so just look at this. Do we have any sort of folders right now? No. Now what we are going, we are just simply downloading our data set. So you can just simply do one thing. You can give a comment part here, like we are downloading the data set. Okay. Now if you run this code, candidate, believe me, it will take some time. It will try to connect with the internet. Okay, now we are extracting the data set. Just look at this. tar.extract all. We are downloading the data set. Now, if you just refresh this now, you have downloaded the data set, and the data set is in a form of what? Flower data. And now just look at this. Inside this flower data, you have one folder that is called the flower photos. Okay. And inside this flower photos, guys, you have everything. Daisy flower, dandelion flower, roses flower, sunflower, and tulip flower. Now, you are not simply downloading and uploading the file from the online sources. You are using the Pythonic approach, right? And you can just simply click on any of the folder. You will get sort of multiple images, right? And if you just randomly click on any of the images, right? Let me just go to this roses folder, and let me just click on any of the random images, you will get this one, right? These are the roses that we are getting, right, candidate? So we have simply downloaded all the data set. Now what we want? We want to particularly create a like flower directory, and the flower directory is not directly in the okay. What we have against constant variable, and this is nothing. You can just simply hit the path lib module, and with this path library module, you can connect with your path. What is the use of this? You can connect with your path. You no need to give the string path, right? And what path that you wants to connect, candidate? You have a data directory, okay? And inside this data directory, where you wants to go? Of course, we know that in this data directory, we want to go this where flower photos. So just simply write this as we want to go to this flower photos, right? Now, if you run this, you'll simply get the flower directory. Let me just show this, right? This is the flower directory that you are getting. Why you are using pathlib? Because comparatively to the OS path, you can simply reiterate all the pathlib, and you can particularly call out all the values, right? With the help of this. Okay. Now let's just quickly go to each folder, and inside each folder, we'll try to pick all the images, and we'll try to append the data in a given X and Y data set, right? So let's just initialize two different variable. One is X and second is Y. And let's just create two empty list here, right? Now in this empty list, we'll try to go to each and every like recursive approach into this folder, and we'll try to pick the data set, and we'll try to get the array from that images, and then we'll append all the images inside the X and the Y classes. Okay, now what we want, we just simply run the for loop. Okay, and we know that we have, let me just simply okay, just simply check this one. Okay, just do one thing. We have the epochs and we have downloaded the data set. Okay, now before proceeding with this for loop, now we have to give again one thing that is called classes. Okay, because we have a 5 different classes now. So CLASSES, this is the 5 classes that we are getting. So the first class is called the DAISY Daisy. And let me just write it. You can take a reference from here, right? And the second class is called Dandelion, DANDELION. Well, you can use the loop approach as well. But why we are doing this? Because we don't want to particularly pick any of the unnecessary value. Because if we are using the loop now, we have to write if and else condition to simply ignore all the text part and any of the unnecessary file that we are getting if we are like extracting the zip file, right? So Daisy, Dandelion, third one is roses, fourth one is sunflowers, and fifth one is tulips. TULIPS. Perfect. This is the classes. And now what we want to give index for each classes. For that we have to give, we have to run a dict comprehension code candidate. So you can use class to index. We want to run the dict comprehension, and how to run the dict comprehension, very easy. You can use the dictionary and you can run the for loop. For I comma C, I is like index and C is the class, and you can use the enumerate function. We are already aware with that enumerate function. Okay, where we want to run this enumerate, we want to run this enumerate over this classes. Okay, now we know that I is the index and C is the class value, right? So you can just convert this directly to the dictionary with the help of key colon value. It's like key value colon the value part, right? And if you just run this, let me just simply directly show this. This will give the index value of Daisy to 0, Dandelion to 1, roses to 2, flowers to 3, and tulips to 4. Okay. Now let's just simply cut this one, and we have created this data set. Okay. Now we want to go to each and every folder, whatever the classes that we have given. Okay. And inside this classes, we'll try to call each and every folder, and we'll try to read out each and every images. So let's just run this. So for class in all the classes, for class in all the classes, so we know that we have 5 different classes. So first we will try to go this class, and inside this class we have multiple images. So what we want to do, candidate, this is called the flower directory part. Inside this flower directory path, we want to use this path as well, and we want to extract all the images of the given path, right? Guys, are you getting my voice now? Everyone just confirm me. Class, Tarun, Spurti, and the rest candidates. Okay, so now let's just again run the for loop. Now why we are running the second for loop? So this second for loop is to particularly read out all the image path in whatever the flower directory that you have given. And we know that this is the flower directory. Okay, so we will try to create a path for this. So how you can create this? Because this you can iterate using this pathlib module. That is the reason we have used this. And inside this flower directory, where we want to go, class, we want to go in class. We have another method that is called globe method. This globe is like, it will try to help us to particularly extract the pattern liking file or data set. Inside this globe candidate, this is like the MySQL or SQL like operator. What you can do, you can just simply say, I want to extract all the path that ends with .jpg. And we know that there might be chances inside this flower data, although we are getting multiple flowers, right? But there might be chances we will get the some like additional files, okay, inside the flowers photos. So what we want, we just simply want to use the globe object. This globe object helps us the regex operation. You can simply call the .jpg files. Now you know that if you call the JPG, this is like the image path that you will get. And what you want, simply you want to load this image in a form of array, right? So that you can simply append the image in a sort of X and Y array. So let's just create the X and Y two empty lists where we can simply append this one. Okay. So now inside this loop class, whatever the things that we will get, it's like in a form of image. So what we can do, we can simply use the TensorFlow. Inside this TensorFlow, we have a keras, right? And inside this keras, we have one method that is called preprocessing. And inside this preprocessing, we have one method which is image. And inside this image, you can simply call the load image. This load image will generally ask for the image path that you have. And we know that the image path is like stored in a form of image path. And this will ask if you want to pre-process this image. So you can simply convert this pre-processed image into the image size that you want. Of course, because there might be chances we will get the images of data of different sizes. So we want to keep the symmetricity. So let's just simply give the target size. We have this additional argument. This is called target size. And we what we want candidate, we want to reduce the size, or we want to reduce the size of the given image's size, and user can control this one. Okay, now once we call the image, we don't want to store the image, right? We want to store the image in a form of array. So let's just create another variable where we will call this tf.keras, and inside this keras again we will get the pre-processing, and you will get this image method. And now this time you will get another method that is called image to array. Previously we were using this load image. Okay, now the best thing is you can directly use this method here directly, right? You no need to use this one. But why we are doing this? To just keep this at simple level, right? Now you can simply pass the previous variable image, and now you're converting your image to the array format. And we know that what we want candidate, we want to simply append our this image answer inside the X list. And what we want to append the Y. Exactly this image belongs to which class? So this image belongs to y.append. You have this na class to index, and we know that if we just call this class na, so this class will give you the daisy, dandelion, roses, sunflower, and tulip. And if we just want to store the data in a form of numerical na, so we know that the first class is called daisy. So and the value of the daisy is called 0. So we are just simply calling this. Okay, call the class to index, and inside this class to index, this is a dictionary. If you just simply give the key, this will give you the value. And the first time the key is like daisy, so the value will become 0. So it will append the value of 0 in the Y. Now if the class value change, so it will append the value of 1 in the Y. So in this way candidate we are doing this. Okay, now we want to particularly keep our data in a sort of like a scale data set. So let me just call this one. We have simply executed this code. Okay, now we have completed our X and Y part. Now you can just simply check X dot shape and Y dot shape. Okay, so this is not an array now. So let's just convert this to array first, right? So now let me just call this np dot array so that we can check this with the array one. And what we are going to do, we just want to keep this, convert this initial X into the new X in a form of array. And let's just keep the data type as like the float data type. You can give you can control the bit size as well. And we want to keep this data in a scaled format. So let's just simply directly divide this by the 255. If we are getting the 0 pixel array, this will be 0. If we are getting the maximum as 255 array, so this will convert the 255 into 1. So without calling the min-max scaling, we are simply converting the data in a sort of like min-max value, okay, without using the min-max approach. Now at the Y part, again we will call the np.y. Okay, now we know that we are simply appending the 0, 1, 2. So there is no use of using the like float 32. This time you can use the integer 32, right? Now if you just simply run this, let me simply run this one. You no need to write the done here. Okay guys, I hope everyone is getting my voice, right? Candidate, is that clear now? Okay, now you can simply go and check the X dot shape. Now just look at this. Just go to Google again and just simply cross verify this thing, right? We are having the images of like 3670. Yes, we are getting the same one. And each images is like in a sort of what? 180 by 180 of the images size. But why we are getting this 3? Again, we already knew that this represent the 3 RGB channel, R, G, and B channel. Okay. Now what we want candidate? Okay, see, because this data set belongs to images part, and for many sort of EDs, like comma y test. You can simply call your train test split. Inside this train test split, you have to give the x and y. Okay, let's just simply call one of the random x so that I can simply show you, okay, this belongs to flower. It's not like something fishy is going on, right? So let's just simply call this x0. This is my array. And how to show this? You can simply use this plt.imShow, and you can simply turn out this array in a sort of images array. And this is the answer that you are getting. Can it, right? Perfect. So you can just simply check. Yes, we are getting the array, but that array is particularly stored in a form of like that image is stored in a form of array, right? Okay. So we are just dividing data set in a random state, or these are fixed one, there is no something new. And we want to keep the sample of both x and y in just a distributed manner. So we will use one another argument that is called stratify. What stratify try to perform, candidate, it will try to manage whatever the sample that you are getting. You will get the maximum sample of the each and every class. It's not like the sample that you are getting belongs to one class only. That is called stratify, and you will give the stratify value as y. Okay, now let's just run this. We have successfully converted our data set into training and testing part. Just give me a second, candidate. Okay, just give me a second. Now what we want to particularly do some like customization of the given images, and we are already aware with that. That is called data augmentation. Now what is data augmentation? Can anyone let me know? Tarun, Vijay, Hemant. Guys, what is data augmentation, Spurti? And the rest 20 plus candidate. What do you understand by data augmentation? So again, I will repeat, data augmentation is a technique where you will give one image as an input and you will apply some sort of pre-processing over the images. That is you are creating multiple samples of a given one sample. You are applying some random flips, random rotations, you are zooming the images, you are increasing the contrast, you are changing the brightness, because the final images belongs to the input images only, right? But to just create more sample, that is the reason you are using this augmented image. And in the same way, the facial recognition system also works. Now just look at this. Right now we have 3600 plus images. Okay, but when we particularly give our face on a phone unlock system, so we'll not simply give our 3000 of our facial expressions. We'll just simply give one images, right? Or like one face at a time. So how does like mobile application simply understand that, okay, this face belongs to this user? Because at that particular stage, that model generally use the data augmentation technique. It create multiple thousands of samples of your given one simple face, and that makes that model to understand this user belongs to this face, right? Okay, so let's just apply some data augmentation technique. Augmentation. This is augmentation technique. And how to do this? You have to simply write this one, data augmentation, data augmentation, and we will again use the TensorFlow. Inside the TensorFlow dot keras, and because this data augmentation is a part of model building na, so you will use the sequential approach, right? Inside the sequential approach, let's just use the list and just try to do some manipulation with the images part. So what we are just trying to do, let's just uh, give some random flips, right? So let's just give some random flips. Okay, you can play with it, right? So what that you want to dot, you can give the random rotations as well. Random rotations, where is the random rotation? You will get the random rotation here, some sort of, yes, this one. Now you have to give the rotation angle, right? So you can give the 0.15. It's like the 15 degree of a random rotation. Again, layers dot, you can zoom in your images as well. Random zoom. Okay, where is the random zoom? Let me just simply write this one. Yes, random zoom. And again, you can give some sort of degree value. It is between 0 to 1, right? Okay. If you want to keep it like more than 1 as well, so you can do this, but it is recommended to keep this between 0 to 1, right? 0 means no zoom, 1 means maximum zoom, right? Okay. If you want to increase the brightness, contrast, so you can do this. So right now I'm just using this set of approach. So this is the augmented layer that we have simply built, candidate. Okay. Now let's just run this. Perfect. So we have simply built this data augmentation layers. Now what we want to build a CNN model, right? So let's just create CNN model. And you know that, let me just show the images of that CNN model again. Inside the uh, CNN deep learning, what we want to particularly give the images as an input. And once you give the images as an input, then we have to decide the convolution layer, and then followed by the max pooling or like the average pooling, then again convolution layer, and then again max pooling and the convolutional pooling. And then you have to keep flatten your layer. Whatever the n dimensional data that you are getting, you will simply transform this data into the flatten layer, and then you can build your artificial neural network. Okay, so it is like input plus CNN plus max pooling plus like convolution plus max pooling plus flatten plus dense layer. And at the output, because this belongs to multi-class classification, so we will use the softmax activation function the way it is mentioned here, right? Okay, so let's just try to build the like the CNN model. Okay, so how to build this one? Again, you can call the models dot sequential, and inside the sequential, okay, the first thing that we want to perform is called the data augmentation. So let's just simply call the data augmentation as a first layer. Before proceeding for the CNN part, we want to give input as an augmented input. Now what we want, the augmented input is like actual image plus some random images of the augmented images. That is a combination of a data augmentation. So you will give this as a data augmentation as a first layer. Now you have to create another layer. So you can just simply write this as layers dot convolution 2D. And inside this 2D, you can decide the individual neuron, and we are getting the 3 channels. So you can just decide the 3 channels as the input, right? And you have to like particularly give the padding as same. And I hope everyone is aware with that. What is padding? Padding is like giving the extra margin of that particular images, so that the corner pixel must be included in the same training procedure as well, right? Then you have to give the activation function. We have to give the rectified linear unit, which is called the ReLU, right? This is the ReLU activation function that we are using. Okay. Now we want to normalize our all data, and we have to use another layer that is called batch normalization. It helps us to normalize whatever the layers that we are building, right? So note that you can also omit the initial input, and this allows us to particularly normalize whatever the model that we are training on. Okay, so you can just simply normalize your layers. Then again, you will try to particularly layers dot max pooling. Okay, inside this image, you know that the max pooling that you can use. Okay, so just simply call this as max pooling, and max pooling you can achieve it for like 1 dimensional, 2 dimensional, and 3 dimensional. Okay, so this is the one part that we have performed. This is all about input, augmented input plus one convolution plus one max pooling. Okay, now you can just simply copy and paste this one, and you can build another layer. So at the another lane, if you want to increase the neuron, you can do this. So it is recommended to use the twice of the initial neuron, right? So again, we are keeping the padding as same, activation as ReLU, batch normalization, and max pooling as 2D. Okay. So we have to use the max pooling, right? But by mistaken, we have used this max pool. Okay. So let's just go to the like import part, and it should be max pooling, right? This one. Okay. Not the max pool. Let's just call this, and let's just simply call the max pool pooling, not the pool part, right? This is the max pooling that we are performing. Now simply copy this one max pooling, and again pass this one as layers max pooling. Okay, now if you want to increase again convolution part, candidate, you know that you can simply copy this one, just hit enter, paste it. What you want to increase the size of the neuron, okay, the number of neuron, and let's just keep everything as same. If you want to again increase the size, so it is recommended. See, if you are using this so much amount now, so you have to make sure you are connected with the GPUs and the TPUs. Otherwise, it will take so much of time to particularly could be like more than 2 or 3 hours as well, right? So it is recommended to use the GPUs and the TPUs, right? So 256 that we are using. Okay, now let's just consider this as the final max pooling. Right now, what we want to flatten our layer. So you can just simply call the layers dot flatten. We want to flatten our array, whatever the array that we are getting. Now, after the flattening the array, what you have to build? You have to build the complete ANN part, which is called the artificial neural network part, right? So let's just simply call the layers dot dense, and inside this dense, again you have to design the, or like give the individual neuron that you want to perform. You can give the activation function as ReLU. And see, because we know that we are particularly training like our model on multiple neurons, so we have one method that is called dropout layers. This dropout will try which neuron or like which layer is not particularly working good or well for the model training. So it will try to drop out the 50% of the data set that you are, or like 50% of the neuron, if this will not contribute in your model training so much, right? And the final that we are using is called the dense layer, and inside this dense layer, let's just try to call the final output layer, and at the final you have to decide the final value of the 5, but we will not write this as a hard coded. You can just simply use the length of the classes that we have particularly created, CLA SSES, and we know that is a 5, right? Guys, can anyone me? Okay, perfect. So this is the final output. The output is not ReLU, it should be Softmax, right? So we'll try to uh, remove this ReLU to the Softmax one, SOFTMAX. Now Softmax generally works on the probability part, and in this way class we have created this complete CNN model. Now let's just run this. So the CNN model executed successfully, and we know that we have to compile that model. How to compile? You can just simply call the model dot compile, and compile is like for the back propagation and the training or like optimization techniques alone, right? So inside this compile you have to give the optimizers, and optimizers for that you can use the Adam optimizer. I think we have simply directly used this Adam, and you can simply give the learning rate. The learning rate should be between 0.001 or 0.002 or 0.003. You can keep any of the learning rate. The least the learning rate that you are giving, the model will try to particularly learn at that particular pace rate, whatever the learning rate that you are giving, right? And because this is not for the binary classification, so in the previous class we were using the binary cross entropy, but right now this is like the multi-class classification, so you have to use this sparse categorical cross entropy. Okay, sparse categorical cross. Okay, now let's just understand this. You can just simply copy this, and you can go to Google and write this Keras all loss. Okay, Keras all loss. This will give you the list of all the losses that you have inside a Keras, right? And you can select the loss as per the problem. If we want to work on the like probabilistic losses, which is like the binary classification or like multi-class classification, so you can use any of them, right? Binary cross entropy, sparse categorical cross entropy. These are the classes kind of loss, whether it is binary or like multi-class. But if you are particularly working on the regression problem now, so you cannot particularly give the binary cross entropy, right? You have to give mean absolute error, mean squared error, Huber loss, log like log cost loss, and so on, right? Really take okay. Now I have successfully compiled the model, right? Now let's just wait for a while. What is the issue? Optimizers is equals to Adam optimizers, the keyword unexpected keyword argument. So we have to correct this spelling. This is optimizer, not the optimizers. Let me just check this one again. Matrices, we have to correct the spelling of this one as well. This is matrices. Perfect. Now we have successfully compiled this model. Now you know that we have to train that model. How to train that? You can simply call the model.fit, and inside you have to give the xtrain and the ytrain part. We have already decided the epochs followed by the capital epochs variable that we have created. And again, we have decided the batch size, and the batch size is simply based on the batch size that we have already created in the starting, right? BATCH batch size. So let's just call this as batch size at the batch size that we have used. Okay. Now you can keep the validation split as 10%. 10% you will take the data set and to try check whether the model is performing well or not, right? So X train, Y train, and epochs and best size and the validation. Okay. Now, before particularly clicking this, because this will take time, what you can do, you can just again go to this and quickly check. You should be on this one. If you don't want, you can just simply go to this. You can click on change run type and then you have to select this one. Make sure, right? Because I am already at this one now. Now just look at this. It will hardly take that much amount of time, but it will take because we are training 3600 of data set and with multiple epochs. I think we have picked, we have given 30 of the epochs, right? So it will take time, right? So let's just try to give it for the 20 epochs rather than 30, right? It will take less time. So let's just run this. And now I'll run this one model.fit. Okay. So just we have to wait for a while candidate. Okay. Because I have look at the speed, right? We are training 3600 of images of data set and just look at the speed, right? It is only due to the TPU's accessibility. And that is the reason if you want to work in this machine learning, not the machine learning, deep learning and NLP tasks, you require lots of consumption of GPUs and the TPUs. You cannot particularly rely like your own software. And that is the reason like we are using the Google Colab, because if we want to particularly train this model on our local system will not particularly capable enough to train that model at this level, right? You can just, I'll just let you know the model.summary that gives us the overall training parameters, right? Just wait for this to complete. Okay, now the best part is loss should be minimized and accuracy should be increased. Are we getting the same? Yes. The initial loss was like 3.57 and now this is at 1.0. The initial accuracy was 0.37. Now this is at 0.58 or 59. Okay, so we are close to 60% of the accuracy and we have completed the 40% or like 50% of overall trainings, right? So let's just wait for this to complete. Is there any questions, class? Is there any doubt? Whatever we are performing. So in this way, we can particularly create the model and calling the data set from the sources that we have available. And this is very popular project, right? We'll try to deploy this project using the Streamlit as well. Okay. So just wait for this to complete. Whatever the accuracy that I'll get, candidate, I'll proceed with that, right? You can just go and change the epoch size. You can particularly play with the rest ANN part and all, right? Because for the time constraint, whatever the accuracy that I'll get, I'll just proceed with the same one, right? So let me just quickly share this notebook with all of you so that you can take a reference of that, and no need to change any code, right? Because right now we are learning, like we are executing the things. So if we just change any of the things, so it can crash like my notebook as well. Okay, you can just take a reference of the shared notebook. Perfect. Now let's just wait for this to complete. Okay, if you don't toggle this now, access will take 1 hour to particularly train this model, right? So you have to wait. Okay. So let me just check my internet because I don't want to particularly rerun my model again, right? Guys, I'm getting like, am I audible now? Just quickly confirm this, right? Because I'm connected with my mobile internet. So that is the main concern, right? Okay, perfect, candidate. So we have trained our model with the accuracy of 70%. Now what you can do, you can just simply change the epochs value to 50th epochs and just try to like re-execute the model and let me know like how much accuracy that you got, right? Okay, so we have successfully trained this model. Now what we want to evaluate our model, right? So let's just evaluate this model, and if you want to evaluate, you have to particularly call two things. The first one is called loss and second one is the accuracy. So just call your model. Inside this model you will get this model evaluate, and we are already we have already used this multiple times. You have to give the X test and the Y test. This will give you two things. The first one is loss and the second one is accuracy. Now let's just try to print both loss and accuracy. So model loss can be given by loss, model accuracy can be given by ACC, right? So it the 80%, see, it's like the previous loss, the initial loss was like up to 3,300%. Okay, so the loss that we are getting is close to 0.79. You can reduce this to 0.079 it's as well, right? But the accuracy that we are getting is like 0.69 or close to 70%. Okay, so this is enough for to just deploy this level of project, right? So now let's just save this model. Okay, and this is again interview point of view concept candidate. If you want to save the deep learning model, so you have to use another method that is called H5, or like hierarchical distribution of your model. This is called HD5 format. Okay, you cannot use the pickle to save deep learning models. Let me very clear. We were using the serialization technique, import pickle, to particularly save the ML model. But if you want to save the deep learning model, you have to write down in a set of format of model.save. Okay, and then you can give your model name as like flower cnn underscore model dot h5. Okay, now let me just quickly go to chat gpt and show you the difference between pickle and the h5 format. So pickle versus dot h5 for ml and dl. Okay, so this will give you the hint, right? So if you're working on the pickle, so you can particularly, like, this is traditional method for the ML models, like, or for the pre-processing, like standard scaling. If you want to store any of the Python objects like list, tuple, dictionary, so you can use this pickle module. Okay, simple to use, easily can be integrated, but the disadvantages is not like it is only specific for the Python one. But what in case if you want to make this for the language compatible, if like the Java developer want to use this model, right? If like some sort of C++ developer want to use this, so you cannot save this model in a pickle format. You have to use this hierarchical data format that is called HD5 format. Okay, so in short, we generally represent this as a H5 format, right? It store the overall structure of the keras and the TensorFlow or the weights, or it is like cross language compatibility as well. So these are the advantages that you can particularly use. Well, although disadvantages we have, not like this simple one with the pickle one, but we have to focus on the advantages comparatively to the disadvantages, right? So that is the reason we are using this model dot save in like HD5 format. It's like hierarchical data format. Okay, now let's just save the classes as well, not in a pickle format, in a like numpy array format. So you can simply call this as np.save, and we have the classes as well. So let's just write this as a classes.npy. If you are saving any np object, so you have to write this as npy. And again, understand, if you want to load load that object, we have to use the np.load method, right? So np.array, you can give, okay, what we want to store? We want to store the classes in a form of array format, right? Now once you run this, so these are the important object that we want to save. Model saved, model saved successfully. Okay, so now you can just look at this. If you just simply refresh this, so you will get two different things. You can ignore this one, flowers.tzz. This is like the 218 MB of zip file. We don't want to use this right now because we have already downloaded this. We have performed the model as well. Okay, now we have this one which is called npy of the classes one. It stores 5 different classes and then followed by the model, which is like in a SD5 format. Okay, now finally what you can do, you can just simply print your model dot summary. Okay, so candidate, these are the summary. Now just look at this, right? The main things in the previous class, the model that we have trained is the overall parameter was quite like 1000, 2000, 18,000, 20,000. Now just look at this, 24,000, not the 24,000. It's like 1 times 100,000, 10,000, like 10 lakh CR. It's like 2 crores of parameters. Just look at the complexities, right? You have trained your models, 2 crores of parameters. Now, whatever the model that you have trained, it's trained on 2 CRs of parameters, and it can take the images of the user of the like whatever the flowers that we have of 5 different classes, and then it can predict the value. this belongs to this class, so and so on, right? So these are the trainable parameters, and these are the size of that particular model. Okay, and that is the main thing about this model that we have particularly created. Okay, so this is all about for the model creation candidate. Okay, so is there any doubt or is there any issue related to this one, class? Let me know. we have successfully we have successfully created our model. Guys, let me know, shall we proceed for this part 2 of this project? Now what we want to create a Streamlit module, a Streamlit web app, where we can simply transfer all the things or whatever the like models or like the data set that we have, and then we can call the Streamlit module to particularly create a web app. So let's just start with the part 2, which is called the web deployment of this project. Like, so let's just deploy Streamlit. My Streamlit app.py. Okay, now the thing is, now you cannot particularly create a app.py inside the Google Colab. You have to call this app.py like sort of the Jupyter notebook, right? But what I want, we have this like app.py. I'll quickly show you that app.py, or let me just write the code again. So let me just write this one, classes, and the flower as well, right? And parallelly, I'll open my Jupyter notebook to show you how exactly this app.py looks like, right? Because you can create the app.py inside the Google Colab, but you cannot directly execute, or like you cannot directly run the code here, right? So what we'll do, we'll just create the app.py. Okay, and let's just wait for Jupyter notebook or like offline Jupyter notebook to execute. Okay, the model.h5 is like of very huge size, right? 95 MB. Okay, my mistake, because I'm running out of internet as well. So let's just wait for this queue. You can just right click this file and you can add new files, right? Now what exactly this app.py is? This is for the Streamlit web app that we want. Okay, so we have parallelly opened the offline Jupyter notebook as well. Okay, so let's just write app.py here. Okay, and save field. Why the field? The notebook has been changed outside the session. Open the, okay, show the difference. You can click show difference. Guys, I'll recommend everyone not to do any changes if anyone using the reference now. So it will change the code as well, right? So let's just save this one. Okay, we have created this app.py, and now let me just open my Jupyter notebook as well. Okay, so let's just wait, open this app.py, right? Now with the help of this Jupyter notebook, now what we want, we just only want this classes.npy, and second is flower cnn model.h5, right? Okay, so let's just, okay, now we have successfully opened this Jupyter notebook. Just go to this new folder, and this is like Streamlit flowers. Okay, now just simply open that folder. You can cut all the part here. Okay, now what we want to simply upload two things. Okay, we don't use the internet, right? Because it will take the internet to upload, right? So what we want, we just simply go to the downloads, and I'll copy my flower and the classes, and I'll simply press Control C. I'll just go to my C drive. I'll just go to the users, and inside the user, I have created the folder that is Streamlit flowers, right? Where's the Streamlit flowers? Yes, this one. Now you can just paste this here. And what we want, you have to change the name, right? Because I have performed this multiple times now. That is the reason I'm getting this as model 1. So let me just rename this as model 5, and this one as classes.npy, right? Perfect. Now class, what you can do, now you can just simply check we got the file here, right? So just go to this new, click on this new file, and we will create a app.py file here. Why? Because we want to check how exactly our Streamlit web app look, right? And you cannot do this using this like Google Colab, right? we use this Google Colab for the model training. Now we have the trained brain, and with the help of that trained brain, you can call the models and you can build the project as well, right? So let's just write the code here. Okay, inside this app.py, the first thing that you can do, you will simply import the Streamlit as st, right? You can call the numpy as np, and let's just call the import os. And because we want to use the URL to particularly hit, see, if we want to upload the downloaded asset, these are my asset, right? Classes npy, model h5, flower tzz, these are assets. If we want to upload this on the GitHub has like their space constraint. You cannot upload the file more than 25 of MB. So what we'll do, we'll just upload the file over the Google Drive. And if we want to call the Streamlit web app to use that Google Drive URL, for that we need to use the request module. Okay, so we will use the request module, requests. We will use the request module to hit the URL and to get the data set, right? And once we get the data set, then we can particularly call the model and predict the value, right? Now user can simply drop the images from the online sources as well. So if we want to convert that images to bytes array, so we have one module that is called PIL. PIL is very popular library. If someone wants to get into the OpenCV or like image processing, they have to use this PIL module where they can simply call the images, they can reduce the size, they can flip, they can like change the dimension of any of the images. If they want to change the color of the images as well, they can do this with the help of PIL module, right? So inside this PIL, you'll get this method that is called image class, right? And with the help of image class, you can perform anything with the images, right? So let's just call the TensorFlow, TNSORFLOW. Inside this TensorFlow, you have this keras, and inside this keras, you can call this model. And what we want, because we have the model, so to have this all the size is 180 by 180. Na? So whatever the images that user gives, we also want to convert that image size into 180 by 180. So let's just write this as a constant variable image size as 180 by 180. Perfect. Now you can do one thing. If you want to upload this over the Google Drive link, so you have to write this one, model URL is equals to your drive link. Okay, drive link. I'll show you how to do this, right? This is the model URL, and what is that? This is my model URL, Flower CNN, and you have to do this for the classes as well. So let me just write this as a classes URL is equals to drive link again, right? But right now we have used this like for the local host, so we no need to require this one, right? Okay, so we will use some try and exception where whatever the user can get data set from any of the sources, like from the local host or from the web URL or from the GitHub itself. So they can particularly pick any of them, right? So we have used this one as for the safe side, right? Now what we want? We want to do some UI and UX parts. So let's just create the, we have the 5 flower images now. So let's just call the flower emoji, and inside the flower emoji, let's just build one dictionary. And the first was Daisy, right? So let's just check with the Daisy one, and you can call any of the images for the Daisy, right? So let's just okay, instead of this now, let's just use this one, right? I'll just go to ChatGPT and I'll just say, okay, I want a flower dictionary of emoji for my flower classification project. And what is that? And this is like this one, Daisy, DAISY. Daisy is the key, and then followed by the emoji. Okay, emoji. Perfect. For TensorFlow popular data set, it will understand and it will give you the Python dictionary, right? Yeah, this is the thing that we want, right? It's like the flower emoji. So let's just simply copy this one. Okay, and I'll just simply go to my app.py and let me just simply write directly this one. Okay, so this is the flower emoji that we have created because we have 5 different flowers now. So So just for some sake of like UI and UX partner, we are just using this one. Okay, daisy, dandelion, roses, sunflowers, and the tulips. Right now, let's just try to download the utility parts or whatever the things that we require. Right. Okay. So we'll create one function that is called download file. Okay. Now what this download file function, it this load. If the like app.py got the correct URL, that it will download the file. There might be chances the file is available in localhost. So at that time it will not hit the URL, right? So let's just run this as URL. And the second thing that you are giving is the path. Okay. And you're just checking if any of the if any of these things is existing, so you can use any of this, right? So if not path, if not os dot path, if this path is not existing, if this path is not existing, EXISTS, if this path, what path? This path. If this path is not existing, then what it will do? This will use the request module, go to this URL and try to get the bytes data of this one. But we know that we have that path. So we are just creating this for safe side, right? So I'll just create a R variable. You can just call the request REQUESTS request module. Inside this request module, you can hit the URL and you want to download this data in a sort of bytes format or in a batch format. You cannot download the data just like in a one go. So streaming is like just try to download in a bits by bits. Otherwise it will hang my like web app as well. So we are just saying this, right? Okay. Now if we are raising any set of issues, so we can just try to raise that whatever the status that we are getting. If the status values is 200, so it means we have successfully downloaded the file status. Okay, so this is the method that generally has been given by this request module, and most probably it is like success for success variable we will get the 200 response code, and for failure we'll get the 404 response code. If you are familiar with the web development, so you generally know this, right? Okay. Now if this path is not existing, then we will do this. Otherwise if this path is existing, so we can directly open the path. So we are just simply writing this open, and what we want, just open path, and we want to open this path in a write in binary mode, right? Or sometimes we also say this as a write in bytes mode. Why we say this bytes? Because whatever the binary that we are whatever the binary data that we are getting, it is like in a form of bytes format. Okay, now see, just imagine, suppose we have downloaded or like uploaded the model of 2 or 3 GB. So you cannot download the 2 or 3 GB at just one go. You have to run a for loop to download the data in a chunk size, and that is called, if you want to get into the data engineering or like big data, you cannot particularly open your big file in just one go. You have to convert that data in a chunk format, right? So you can just simply call your for chunk in this R is like this R has the bytes data, so you can just iter all your data. So for that you can use this R dot iter content. Okay, and inside this iter content you can decide the chunk size. Okay, and the chunk size, if you keep it low, so it will take like much time to download all the data. If you keep it very high, it can crash your websites as well. So you can just write any of the values, right? Okay, so let me just write this one. You can play with that, write the chunk size, right? And it is completely based upon the internet speed as well, right? Okay, now if you got any chunk is like if it is true, it can be false or it can be true, right? So let me just increase some spaces. Okay, if it is true, so what we want to download this data. So how to download? Because we have opened this path in a write in bytes format, so you can just simply say now, okay, go to this file and write this whatever the chunk that we are getting. The chunk is like, it's like the bytes data, so we are just writing the chunk data. Okay, now if someone run this for loop now, so they can simply get this data, okay, in a bytes format or like in a write in binary format, and that is like your whatever the file that you have, it's like the path format. Okay, perfect. Okay, so this is all about for this method or like this function. This will download the file. Okay, now what about the rest part? So what we want to download the download important assets. So let's just write this as comment download important assets, and we know that we have used this module now. We have this function, so we'll try to download this function with the help of, and what we want, either just try with this one model url, okay, or just try with the model path that you have. Now where is the model path? Okay, so just below this, again create one more thing that is called, we have the model path as well. Okay, and what is the model path? The first model path is my this file, that is flower underscore cnn underscore model.h5. So you can just write this flower underscore cnn dot model.h5. This is your first path, and the classes path you can give CLASSES classes path, and this is again the file name of this one. This is like classes.npy. So let's just write this as classes.npy. Okay. Now what we try to do, we try to download this file either with the model URL or with the model path, whatever the thing that we have, right? Model underscore path. Although we have this right now, but we are just calling this. Okay. Now let's just call this again with the classes URL or like classes path. Classes URL, and second is with the classes path. Okay, so we have created this one, the classes path. So we are calling this, right? Let's just check the spelling because we don't want to get any errors, right? So the first one is download file, second one is download file with the model URL and the classes URL. Okay, now once we got the model, so we can simply store that, right? And we have used this method that is called load model, right? So you can call this load model, and where you will get the model. Of course, you will get the model from the model path, right? This is the model, right? You can call this model. Perfect. And what you can do, you can call the classes as well. And how to call the classes, you know that you have this method that is called np.load, and you can call this path, right? Perfect. Perfect, candidate. Okay, we have successfully created a model and the classes as well, right? Now let's just try to build the web app. Okay, so you can just give something like this, uh, build web app. And how to build? You can just use the Streamlit st dot. If you want to give the icon for like this, you can give the page configuration st dot set page configuration config, and inside this page configuration you can set your page title as well. Page underscore title is equals to flower. See, we are getting the title as app.py, so in the same way we will get this one. CLASSIFICATN classification using CNN. Okay, so this is the page title, right? Now you can give the page icon as well. So let's just call any of the icon of the given images. I think this one is good. So let's just call this one. This is the dummy icon, right? We are using this. And let's just keep the layout. You can change the layout as well. Layout, and the value of layout is like, you can give the centered one. You can try the different values, CENTERED, right? So these are the by default configuration that we want to use for this flower. Okay, so now let's just do one thing. Just copy this, save this, and just go to this new. Okay, and do one more thing. Just go to your drive folder. So for the safety part, what I have did, candidate, I have simply uploaded this file, right? So because it will take like my internet consumption, or let's just upload this, right? I'll just go to this. I'll simply go to my drive. Okay, and I'll upload the same one, right? So let's just create this new folder. Okay, I'll create a new folder. Just wait for a while. Just click on this, click on folder, not the folder upload, just a new folder, right? Where's the new folder? New folder, yes, this one. And you can just say, where's the new folder? Just wait, right? Yes. And you can just say CNN flowers assets. Okay. So we have created this folder CNN flower assets, and inside this CNN flower assets. So let's just go to this new, click on this file upload, and just go to your same locality, the folder that you have. You see user, and inside this we have this, where's the Streamlit flowers, and simply uh, call this one, right? And just simply upload this, right? So let's just check my internet. Guys, are you getting my voice now, candidate? I'm audible now. Can anyone confirm me, guys? It's already like 1.5 hours. Just let me know. Okay, Taruna, perfect, right? See why I'm asking this now, because I'm connecting with my mobile internet, right? And it can be consumed at any time, right? This is the issue. Okay. So let's just wait for this to upload, and what I'll do, I'll just because I've successfully used this one, so just go to this classes.npy. You can just click on this share, and once you click on this share, now first you have to keep this public, right? You can keep this public. So let me just wait for this to complete. Then we have to simply call our model, and we'll just pass the data set, so and so on, and then the project will be completed, right? So sorry, sharing is unavailable at this time. What is the issue, right? Let's just click. Is there any internet issue? Let me just check. I think- Okay. I'm getting. I'll just wait for this to complete, right? Sharing is unavailable. No issue. Let's just wait for this to complete. This is due to this one, right? Okay. So what I'll do, candidate. Okay, let's just first click on this and go to this one, right? So with open path and write in binary and something, this is that. Okay, so we are downloading this data, right? Okay. Now the best part is we have already this module, right? So what I want at this time, I don't want to run this code, because we have already this one in the local host, right? So why we want to upload or like download it using the internet, right? So let's just go to my terminal. I'll click this terminal. I'll go to my like app.py, and I'll first hit this one, Streamlit Flowers. This is the root directory, right? And then you can run your like project here. So you just go to cd dot dot and cd dot dot, and then you can use the cd user. User is not there. Okay, yeah, we are already at the user. So just write the cd Streamlit. Streamlit, not stream, yes, Streamlit Flower. And inside this Streamlit Flower, what we want, let me just first clear all the commands. And inside this, we want to run our this codes Streamlit run app.py. We are doing this for the local host, right? Because we can directly like upload this using the GitHub, and just look at this, right? Uh, what is the issue? Module, no module name TensorFlow, no module name TensorFlow. How is this possible? Import. Okay. Okay, no module name TensorFlow. Okay, I know that this is due to the we don't have that module, so I need to install that one, right? So let me just, it will take time, right? It will take time. So let me just click on this terminal, and I'll just try to pip install the TensorFlow, right? If I'll just do this now, it will consume my internet, right? So let me just check pip install TensorFlow. I don't think it is required to like install this. Let me just check my spelling, right? TensorFlow from TensorFlow. Yes, I have this one, because it is already the part of Anaconda distribution, right? From TensorFlow. But why it is required? Let me just check. Okay, I'll go to this, pip install TensorFlow. I'll simply copy this one. I'll just paste it here and wait for a while. Okay, it will download my all modules. Okay, it's successfully requirement already satisfied. Perfect. Okay, now I need to about this, right, candidate, because I don't have that much internet. So let's just about do. I'll just simply, okay, let me just do one thing now. Let me, okay, I have that module. Okay, I have this one, the Keras TensorFlow models dot and everything we have. Okay, now what I do? Okay, just see, this should be here, right? I have this TensorFlow module, but why it's not particularly showing here? Okay, so let's just do one thing, right? Let's just simply like create an app, and then we can simply run it over the directly with the GitHub, right? So let's just we have successfully configured the our page icon. So what I just simply want to particularly do some more UI part. So let's just do this. So you can just simply go to this st.sidebar, and then will like, and here you can simply give the CLASSIFI flower classification project, right? So this is the title that we are getting. Perfect, right? Now, if you want to write something more about this, so st.sidebar.markdown, okay, and you can just write the things. Okay, so let me just copy this one, or I'll yeah, I'll just simply write this. I'll write more about this. Okay, let me just keep it right now. Okay, so now let's just move to the deployment part candidate. Okay, so we have used this st.sidebar.title. Okay, st.markdown as well, right? So what we want to we want the user to upload the file, right? So for that we have to use this st.file uploader. Okay, st.file uploader, and you can just decide the file uploader size, or like the type of the file type that you want to upload. Okay, so you can just give some prompt to the user, upload a flower image. Okay, and if you want to give the images for the emoji for the image as well, so you can just simply give the emoji as well, right? So let me just write this one, upload a flower image. And once you get this, then you can simply give a type, like what type of image that you want to allow. So the first one is called JPG, second one is called JPEG, okay, third one is called the PNG, and the fourth one is like the WebP. These are the main popular file extension. Okay, so we have used this one that is called st.file uploader. Okay, why we are using this? Because we want to particularly allow user to upload this file. Okay, now there might be chances user will not upload the file. So if the file is uploaded, or if the bytes data is not null, so uploaded the uploaded file is not none. If the uploaded file is not none, so what you will do, you will just simply go to image. What is this image? This image that we got from the PIL, right? You will go to this image, and this image will open that particular image, and it can download that file. Okay, so what file? It will first open the file that user has given, and then it will convert that file into the RGB format. So you can give this as like RGB format, right? Now what we want, let's just show this image with the help of st.image method, and you can give the image value, this variable, and you can just give the caption as well. Caption is like user has uploaded this image, so you can give this as the uploaded image, right? So this is the image that the user has uploaded, and if you want to keep the width and height as well, so you can just simply write this as a width is equals to 200, right? This is the by default width that we are using. Okay, perfect. So if the image is not done, something this, right? Now inside this we want something the button where user can click, and that it will try to take some time and then predict the value based on that, right? So let's just try to build that one, right? Okay, so how to do this? We have one method that is called st.button. So user must click this button, right? st.button, and if user will click this button, so you will use this if. So this st.button either give true or false result. So if the user click on this button, so inside this button, I'll just write this as a predict flower. Okay, and I'll just write this one as the predict flower. If the user will click on this button, so the app should take much time, and for that, how I can do, I can just use this st.spinner, and I think I have already used this in the last class as well, right? st.spinner, and this spinner allows us to like hold the result for some sort of second, right? Although we can get the result directly, but we are just holding the result for some sort of setting, right? So you can just simply say this as analyzing ANALYZING, analyzing image dot dot dot. And what we are analyzing image, so you can just call that image whatever the image that we have. What image? So we have we have that image in a form of image variable, so we will call that image. And what we want class, we will try to reduce the size of this image because now we want to feed this to the model, right? So we will just resize this. And how to resize this? You can have this method that is resize, and inside this resize you can call the image size that you have, the constant image size that you have just created, that is called image size. We want to keep each image size at the value of 180 by 180. Now if we have resized this, so you can just store this inside the image resized. Now what we want to convert this using the array. And if we just convert this array, then we can predict the values using the model that we have. Okay, so let's just write this as image array. Image array is a variable where you will call the np.array method. Now what this array method will do, it will just simply call this as image resized, whatever the resize that array that we have. We'll just simply pass this inside the data type, and data type that we generally picked is the float 32. And we know that we have to keep this at the scale level, that is min-max scaling. So we can simply divide this using the 255. Now this is the array, and we want to pass out this array in a sort of like a 3D channel we have. So we can just expand the dimension, and that is called expand dimension. We have that expand dimension in a np dot method. You can call this as expand dimension. And what you want to expand, you want to increase one dimension. If we have a 2D image, we can convert this to 3D, and so on, right? So you can just give the axis value, right? At 0 axis we want to increase the dimension. Now we have this image in a form of array candidate, and we know that the model generally takes like array as an input, and it can predict the class, right? So you can just simply write this as a predicts what model has predicted. So first you have to call the model, and inside the model you have this method which is called predict. Now this will call this predict, this will call this image array, and the value lies inside in 0 format. So you can either you can call this 0, or you can directly call this while calling the if else condition, right? Now you have to call the class index as well. Now exactly this class, this array belongs to, or this image belongs to. So you can call the, if you want to call the class index now, guys, are you getting my voice now? Hello everyone. Okay, so you can, if you want to call the class index, so you can call this np dot argmax. Argmax will give you the maximum, like index of the maximum array. And we know that because we are using the softmax function now. So the softmax function is like, it can predict the daisy, tulip, and dandelion as well, but we want to predict the probability for the maximum one. So that is the reason we are using this np.argmax for whatever the predictions that we have performed. Why we are writing this as a prediction? Because we will get the prediction for the 5 different classes. Okay, now what I want, I just simply convert this into the percentage, and that percentage is nothing, it's called the confidence value, right? How much my model is confident. So I'll just simply say whatever the maximum that whatever the maximum value that I will get from where, from this prediction. Okay, you can simply convert this into the percentage using the 100, like we will get the 100 value. Right now we have predicted these classes, and now just look at this. Inside this we have used this one as the classes, and where we have the daisy as like the 0 1 dandelion 1 2 and so on, right? So we just want to particularly reiterate the same, and we want to get the flower name with the help of a class name, and we call this as a classes with like this one. Okay, and inside this classes we have the dictionary. So how to call the flower name? You can simply call the flower name is equals to flower name is equals to, you can call the classes, you have that classes, and inside the class you will give pass the class index, right? You pass the class index, right? आपका कॉल आ रहा था. Now we have that emoji, na? So you can just call the whatever the flower name that we will get, so we will give the print the emojis as well, right? So how to get the emojis? Just simply call your dictionary, and inside this dictionary you will have this method which is called get, and inside this get you can give the flower name, and whatever the flower, if you will not get any of the flower, so you can give any of the random flower, right? So let me just write this one flower, and you can call the random flower, right? If you will not get the actual flower, right? So although, but you will get the like the flower, right? So now you have called the model as well, you have predicted the value. So of course you want to show the value, right? So if the button is clicked, see everything that you are doing inside this with the spinner, right? Once the spinner got like perform everything, then you want to show the final value, so you can use this st.success, and inside this st.success class you can use the fstring method, and you can just write the like markdown as well. Let's just use the 3 hashtag for the like 3 markdowns, and you can show your emoji, right? This is the emoji that we have, and for that particular emoji we have that prediction, and the prediction is like in a form of flower name. And where to get the flower name? Why we are using this? For the markdown, right? And you can get the flower name as like the flower name, and you can make it as upper, or you can use the capitalize as well, CAPITALIZE, capitalize, to make this as like first character as the capital. And why we are using this success is like for the green tick result that we are getting. And we want to show the confidence as well. So if you want to show the confidence, so you can use this info, and for this info again you can use the markdown technique. Okay, and this markdown you can use the graph to just show the confidence. You can use this graph, and inside this graph let's just pass this as confidence. And where to get the confidence value? Again you will use the markdown technique, and this double star is to make the answer bold, right? And where to get the confidence value? Let's just keep the confidence value as this one, and we want to keep it for like 2 decimal float value, so you have to use this format technique is like .2f. Okay, candidate. So in this way we have successfully created this app.py. Now let's just try to show the st.markdown, and inside this markdown you know that st.markdown. Let's just go to this GPT, and where's the GPT? Is this one, and you can just say give st.markdown for my GitHub and LinkedIn link, and made by heart, like this. Okay, it will give you the st.markdown code. Okay, I'll use this one, made by something this, and href for the GitHub and for the something like this. Okay, so let me just copy this one, and I'll just use it here, right? So can it, in this way we have developed this like app.py. Now why I'm not running this one? Because it will consume my internet, because I have to upload this one over the like Streamlit as well. And then again I need to like install the TensorFlow module, right? So it is better to like particularly develop your website with the first of all with the local host. Then if you are satisfied with that, then you can probably upload that, right? So now what I'll do, I'll just simply download this one. We have that particular folder, right? Okay, now one more thing, you have to like pass the drive link as well. So let's just again copy this one, click this one. Now just click on this share. I hope it should work, right? So what I'll do, I'll just simply copy the drive link, and with the help of that drive link I'll just pass the module. If the file is not uploaded on the GitHub, then it will be downloaded from here, right? Okay, let's just wait. Okay, why the like sharing option is not available? Let me just share this again. Okay, am I audible now, candidates? Okay, I'll hardly take like 10 to 15 minutes, then we will simply deploy this model, right? So let's just cut this one. Okay, see why the recording has stopped, right? Recording has stopped automatically. Was it something issue? Like, let me just start the recording as well. Okay, why I'm getting the like something like this? Let me just again click on that, manage recording. The recording is working fine. The video call is being recorded. Okay, just click on that. Okay, so these are the classes. Just click on that, go to share option. It should like particularly give you the share link, right? Once we get the share link now, so what I'll do, I'll just simply go to this app.py and I'll paste my drive link here, right? Just wait for this to complete. Okay, if this will not work, so not such issue candidate, what I'll do, I'll just quickly show you the final project, right? So let me just go to my Streamlit. I have simply deployed all the things, right? Because I know that this will create such issue in the final part, right? So let me just go to my Streamlit directly, and I have deployed this project for your safety, so you can just take a reference of that. Is there any issue with my hello? Am I audible now? Can anyone confirm me? Manage recording. I think recording. Is there any issue with the recording, right? I think the class is on recorded, right? Okay. Because I don't want to miss this part, right? Okay, class. So I have already like uploaded this module. Okay. So you can just simply go to this one. Okay, right. And you can just click this one. I'll show you the code and all, right? How to like particularly give that drive link. Okay, if this will work, I'll definitely show you, right? Let me just try this again. Like, why it's not working, right? Yeah, it's perfectly okay. So just go to this, anyone with the link. Now copy this link. You can copy this link. You can go to this done. And where's the classes.numpy, right? You can just click on this and you have to give the drive link. Okay, now just understand one thing. When you paste the drive link now, when you paste the drive link like this, so this will give you the something view like option here. Okay, you don't have to give like this one. What you have to give, you have to simply keep the sign same like this. Okay, and instead of this file, you will just do something, one thing that is called, just remove this file, and after this .com you have to write this one. UC is like the overall value, and just make this as question mark. This is optional parameter, and you have to give the ID value as 1. Okay, this is the thing that you have to do, and just quickly remove this one. Now you have to keep this one like this. Perfect. So I'll just simply apply the codes here, and this is my the first drive link for the classes one. So let me just pass the drive link here. Okay, and I need to repeat the same step for the model one also. Okay, so just copy, click on that, click on this share. I think that was for the model itself, right? So click on this share. Okay, click on this share. I'm not getting the share option, right? Let me just click on this share, quick share option. See, again, I'm getting some sort of issues, right? So no issue. Let me just try this again. I'll just refresh this one. Okay, go to, you can directly share it from here also, right? Let me just try this one. I'll click on this one. Okay, yeah, perfect. I'm getting the option. Now just click on this, anyone with the link. Okay, copy that link. Now you can even, you can run your project as well with the link as well, right? Okay, if you copy your link, you have to just simply go to this. This is the model, like model URL. So just simply paste it here, right? And once you paste it now, again, you have to just change this to, instead of this one .com, just simply pass this as UC and keep the ID value is equals to this one. Okay, not with the slash one. And then simply remove that path as well. Perfect. So this is the model path. Candidate, perfect. Now what you have to do, simply download all the things. Now just go to your Streamlit module and go to Streamlit login. And what you have to do, you have to simply upload your all app.py, and just only app.py is enough, right? Why? Because it will get the data from like the classes or like the flower value from the drive link that we have, right? So just go to this one, click on that create app, click on this deploy. Okay, first you have to deploy all the project to the GitHub link. So just go to this GitHub, create a new repo, right? Click on this create new repository, and you can give the repository name as like this one, uh, five flowers classification. Okay, using CNN. Okay, you can give this one like this using CNN. Perfect. This is 5 flower classification using CNN. So let me just keep this as public and I'll create a repository. I'll just try to upload my app.py and second thing as the requirement.txt. Okay. So just go to this upload file and simply you have to go to upload file, right? Let me click on this, go to this upload file, and inside this upload file you will get the option of app.py. I'll just simply go to my app.py. I'll call my app.py. While see, I'll not upload my rest asset because it will consume the it will not consume, but it will not allow us to upload you like more than 25 MB of file. Let me just show this, right? If I just try to upload this file now, so you can just check the file size is like bigger than 25. You have to apply something like more like lower than this. Okay, so let me just quickly upload the app.py only. Now once you upload the app.py, now what you want to give the requirement.txt as well. Okay, inside the requirement.txt now, this will allows the Streamlit, okay, which are the modules that we want to particularly run this set of the web app that we have, right? So requirement.txt is completely based upon the whatever the module that you have during your training process, right? So you can just simply write this as requirements dot requirement not comma dot txt, and inside the requirement, yes, perfect. You can just simply write this Streamlit. First we want the Streamlit, second is like TensorFlow. Okay, second is like TensorFlow, and third is like NumPy. Fourth is Philo module to import the images. The uh, G-down image to download and to maintain the stream, right? And if we want to perform the OpenCV as well, so we can do this for the the image resize and all, right? So OpenCV Python. Okay, let me just copy this and I'll just take a hint from GPT. If there is any wrong, then it will just give me, right? Give requirements.txt for this one. Okay, it will just correct and give me again, right? So for the web app that we have, yes, Streamlit, TensorFlow, OpenCV, Python. Now let me just copy this. I think everything looks same. Okay, so require MENTS, just simply comment this out, comment this out. Now just go to your deploy an app, Streamlit, simply select your 5 flower, whatever the project name that you have. It's like 5 flower. Let me just refresh this again. It's like 5. It should be 5 flower, right? But I'm not getting this one. Okay. Let me just check with this one. It's like 5 flower classification using CNN. Na? So this is the module name. Let me just simply refresh this. I'll probably get this time, right? Yes. 5 flower CNN. Now what you have to do, just simply select your main file and the app.py file, and you can just simply give your like the Streamlit web app URL. So CNN flowers. Okay, let's just keep this as the domain is available, so I can simply give this one CNN flowers, and let's just deploy this, right? Once you click on this deploy, it will try to download the important information from the data sources that we have provided. And what is that? These are the app.py, right? Okay, and it will try to download the dataset from the given URL. Perfect. And then it will take some time to particularly install all the modules, and then our app will get ready, right? Let's just check. If we face any sort of issue, then I'll try with the another one. Guys, any issue or any sort of questions as of now, candidate? I hope everyone is getting my voice. Class, is that clear? So let's just wait for this to complete. Okay, now we are getting something perfect. Okay, let's just turn this off. And if everything is perfect, then I'll get the final result, right? So let's just wait for this to execute. Now you can simply give the, see, I'm getting module name TensorFlow. What is that? This app has encountered the original error message, dedicated data leakage, manage app, click to callback. Let me just click on this. No module name, Tensor TNSOR TensorFlow dot oh. The mistake is Keras. Okay, so let's just correct this. See, that was the main reason we are not getting this, right? Keras. That is the reason I was thinking, because the model should run perfectly, right? So let's just try to run it for the local host as well, right? I'll just simply press Control C. It will stop my terminal. I'll just hit the CLS. I'll run my module again, app.py, and this should show me the result as well. Okay. See, this is for the local host. No module name, TensorFlow, no issue. Let's just do the changes for the actual app, and the inside the actual app, let's just change this to from TensorFlow.keras. Let's just simply check this from TensorFlow.keras. I'll just simply copy this one and I'll just go to this. Just say correct this one from TensorFlow. It should be .keras, right? From TensorFlow.keras. It was a by mistake, right? So you can just go to this edit option and you can just change the file, and let's just save it and commit the changes over the GitHub, and it will just reassign, or like it will reboot the app. And now, yeah, you are getting the result, candidate, right? This is the previous one. Okay, but that was for the previous one, right? This is the project that I have created, but here we are getting some sort of issue, right? What is the issue? Let's just check. File not found error. Where is the issue? File not found error. No such file not found error for flower cnn model.h5. Well, okay. Again, I need to do one thing, because I have commented this out, right? So you need to again turn on this so that it will download the files, right? So that just first click this edit file. Okay, it's okay. I think my internet is like, okay, so just go to this one and simply remove the comment out, right? Now you can do the commit changes and again go to this. It will again reiterate, reboot the app. If we again face the issue, then I'll show you the my updated one, right? Okay, so let's just check. Now it's working perfect. Okay, candidate. So what you can do, you can just simply go to this one, right? This is the drag and drop, upload a flower image. You can just go and check the like st.title, so and so on, right? You can just go to this one. Okay, I'll just simply copy this code. I'll just go to my GPT and I'll just say, make this as dynamic and keep some changes for sidebar like tech stack. I have used tech stack used and markdowns. Okay, markdowns. Okay, also show title for my project. Okay, I'll just try to like keep some changes in my project, right? Well, although you have to do this manually, but right now we can do this, right? Because we have implemented the main things, right? So these are the like the configured and so on, right? The configuration. Okay, these are the tech stack that we are using. And where's the title? Where's the title? Where's the st.title? The main thing is missing. Yeah, this is the title. Okay, now let's just, okay, let's just copy this one. See, this is the same, right? We have already like created this. Everything is same, like nothing so much issue in this. Okay, now just go to this, click on this, edit this file. So you have to just simply paste this one, do some commit changes, and here you will get the updated one, right? Just look at this. Okay, this is the updated one, candidate. Flower classification, although you have to write it from scratch, but the best part is, right, we have used the GPT to just correct this one, right? Okay, now what you can do, you can just simply go to Google and just look for this rose, right? Now just simply pick the rose image, go to your like Streamlit model and drop it here. It will download. It will just you will get the image which is called the predict flower option. If you click on this predict flower, it will run, and here you are getting the answer, right? And the answer that you are getting is like, candidate, prediction is roses and the confidence is like 71.49%. And this is the project that we have created. And now the best part is this project is live. You can just simply copy this URL and let me just share this with all of you so that you can take a reference of this. And the URL is also very easy, right? HTTPS CNN flowers.streamlit.app. Now, if you just click on this URL, even you can run this on your local host or like on your mobile devices as well, right? So now let's just so in this way, candidate, we have implemented a CNN project from scratch. We have created a model. We have got the data from the online sources. We have converted the data into the X training part and Y training part. This is the notebook that we have used, right? Okay. And this is all about for the CNN implementation. We have used the data augmentation technique. We have created the batch normalization and all, right? Compilation, training part, testing part. We have saved the model and look at the parameters, right? And then we have created this app.py where we have like imported or like uploaded the main asset to the Google Drive so that it can directly load it from the Google Drive. And this is all about the REST code, right? Now user can simply drop the images and it will get the predict flower method, and once it will click on it, then it will give you the final like prediction. Okay, and with the confidence as well, right? So let's just try with this one as Tulip, right? Let's just try. It's not like, see, the model is trained at with the 70%. It will not give you the accurate result always, right? But let's just try with some other sort of images, right? So now I'll just go to this one. I'll just simply call my image. I'll just go to my web app. I'll browse. I'll upload that image here, and you will get again the predict option once the image uploaded successfully. Yes, you're getting the predict option, and if you just click on that predict flower, okay, it will try to run the model and you are getting the prediction as Tulip with the accuracy of 99%. And I think, candidate, we have developed like a proper end-to-end website for the client, and even you can use this too as well, right? I hope everyone is getting my point, guys. Are you getting? Tarun, Spurti, how's this project? I hope everyone is liking this, right? Just let me know, candidate. We have built a project where we can simply like we can give the images of the given classes, right? Dandelion, roses, sunflower, tulips, and the daisy. Now let's just check with the sunflower one, right? Sunflowers. Okay, so you can just again call any of the images. Just simply try to pick this one, right? Go to your model, go to your website, pick that image, drop it here, and wait for this to execute. You will get the method as like the predict flower, and let's just wait for the answer. See, the confidence that you are getting is like the 67%. Well, the model is not good enough to particularly give you the accuracy of like 100%, because the model itself was trained on sort of 70%, right? So in this way, candidate, you can particularly like build the project like this. And I hope you will get some sort of insights how to get the data set from the user. Now just look at this. If we have the like facial classification for the actors facial images, right? You have like 10 to 20 different set of facial images for different actors. You can download that data set. You can use the same approach, right? You can use the same tar approach to particularly unzip that file. Then you can use some data augmentation technique to train that model. You can build the app.py where user can simply particularly like drop the images and predict the images as well, right? Now I'll give you one homework. What you have to do, you have to update some features in this app where user can give camera access. Okay, user can give camera access, and with the help of that access, it will click picture, it will take picture. Okay, it will take picture and predict class. Okay, okay, if the given picture, if the given pictures is not, yeah, not belongs to any of the classes, any of the trained classes, okay, it must show different images. It must show user has uploaded different images or like other images. Okay, you have to create like or add some features in that particular web app that we have built. So guys, everyone, like I have already shared this URL with all of you. Okay, you can of that, and let's just connect tomorrow. And this is for the today. We have started project, we have built the project from end to end deployment. Okay, so you can take a reference of the two notebook links shared, and let's just connect tomorrow. So wish you all the best, candidates. Bye bye.